Hi there, I'm Anton from Anton's MINDSTORMS Hacks. In this video I want to show another version of the Python snake that I made. At least it's a Robot Inventor snake. As you see, it's quite a large model because I connected no less than 3 Robot Inventor hubs here. And last time I programmed it with word blocks, so that's scratch blocks inside the MINDSTORMS program. This time I programmed it in Python because Python has to be programmed in Python. And because I was able to program this one in Python, it's got a lot of nifty extra features. For instance, right now you can remote control this snake with the app. So I have an app in the Google Play Store called MINDSTORMS RC BLE. So it's a Bluetooth low energy communication to the Robot Inventor hubs here. And you can catch the data from the app inside a Python. This means you can remote control the snake. Let's first try remote controlling this one with one segment, and then let's try it with multiple segments. Here we go. Okay, let's first rebuild this snake into a single segment snake. Now is a good time to hit the subscribe button if you like Robot Inventor robots or any MINDSTORMS robots really, because that's what I build. I like to build animals with nice animations that look really lifelike, and you'll learn a lot about programming too. There we go. Almost there. That's a nice thing about this model. It's completely modular, so you can replace the last segment here with a tail, and then we have a single segment little snake. Let's turn it on and connect it to the remote control. Okay, let's turn on the program. I downloaded the program in slot 0 for remote controlling a single segment snake, and once it starts you can see the scanning animation, and it's waiting for the remote control app. Now I already downloaded and installed the app, of course. Once the snake is in connection mode, I can scan, and it found the snake here. It says snake, and then I can press the connect button like this, and the snake here starts beeping. This means it registered a remote control app, and I can start driving it around. Now let's go over to the floor where we have more space to explore this. There we go. So now in this version of the remote control app, I have created a setting here that changes the delay between the segments. So if I set the segment this setting here to 0, this means all segments have the same curvature. That of course doesn't make the snake move. In order to make the snake move, you have to set a little delay here between the segments like this, and then I can get the snake to move. And the interesting thing here about remote control is that you can play with the delay between the segments and try and find out what the best movement is. If you set the delay too small, it starts shaking a lot, and let's set it to 0. So then it turns into bananas. It goes bananas. And if we set the delay too high, it starts to wriggle and topples over. So that doesn't work either. The sweet spot is somewhere in between here. For me, a setting of about 200 here works best. Let's put the snake back up straight. Now we can drive the snake. Of course, you can also turn it. Turn it some more. And it's not really useful, but just for the sake of it, I programmed the buttons here to change the light. So button 3 turns the light off, button 1 turns them full on, and button 2 dims them about 50%. Maybe it's a bit hard to see like that, so this is on, 50% off. So this is just because I wanted to show the functionality of the buttons here in the app. They just throw some switches that you can catch through Python here on the hub, and then do something useful on your robot with that. So let's drive around some more. The building instructions for this snake are in the top right corner of this video, and you can also click the link in the description, or you can build your own snake. This model isn't that hard to build, but I paid special attention to a lot of details in this model, so you might as well support me, my work, and all of the hours I spent programming this by downloading a model there. Thanks a lot already. Okay, so this is a lot of fun, having the snake with one segment, but the really cool thing is, of course, a multi-segment snake. So let's scale this one up. Okay, let's disconnect the tail part here and move it back to the end again, and reconnect the connection bits. If you haven't subscribed yet, now is a great time to do it. There we go. It's connected. And let's go over to the tail. The tail is very simple to connect. You just take it off like this and connect it like that. Now we have a full tree hub snake here. It almost doesn't fit the camera. Let's power it on and make it drive. We'll start by powering up the rear segments here. So this is program 1, this is program 2, and you can see that it says snake 1, S1, and it does the connect animation. Same here, S2 does the connect animation, and the snake head program is in slot 1. So let's power this one up, see what happens. You can see it connects to the rear segments, and the first thing it does, it starts driving in autonomous mode, in which it avoids walls and slitters around the room. Now, to get it out of autonomous mode, I can just use the app here and connect to the snake, and then it goes out of autonomous mode, and then I can just start piloting it with the sticks like I would a single segment snake. So there you have it. Ain't that really awesome? It's a huge multi-hub snake that you can remote control from a MINDSTORMS app. It took me weeks and months to program this, but I'm kind of proud of the end result here. It's a Python in Python, remote controlled with an app. What's also interesting to note is that the movement in Python is rather smoother than the word blocks movement. I'll try and make it go a little slower. And you can see that the movement is pretty smooth. With word blocks, it used to shake a little bit every second from time to time, as if the hub was doing some overhead processing because of the word blocks. And here the Python program is really closely connected to the core hub. I can of course disconnect now, and the snake goes back into autonomous mode and starts crawling around. Okay, so the snake is reconnected, and we're going to end the program by pressing the 7 button. That's how I programmed this button, and you will see it powers down and all the beeping stops. This here concludes the video about the LEGO Robot Inventor snake programmed in Python. I hope you enjoyed it. Remember to subscribe and tell all of your friends to subscribe. If you want to build this particular model, I have a link in the top right corner there, and it links to my website where you can find building instructions for this one. You can also build a snake of your own. It's not that hard to build this snake. It's just a series of motors that are connected to each other, and they turn into hinges. So you can design your own snake or download my building instructions and build this one. The nice thing about the building instructions that I created is that the snake is of course completely modular, so you can connect as many Robot Inventor hubs as you want, or you can just create one snake. It works just the same. Enjoy building and playing with Pythons and robot snakes. See you in the next video. Bye bye.